I'm going to do some problems from the Unit 4 Worksheet 1, and we're going to start by taking a look at number 3. The instructions are to find an equivalent rational expression in lowest terms and identify the values of the variable that must be excluded. So we have two things we need to do on these problems. So first on number 3, we're going to reduce this to lowest terms. I'm going to look at the 30 and the 24 and ask, what can I divide both 30 and 24 by? In this case we could divide them both by 6. 30 divided by 6 is 5. 24 divided by 6 is 4. And then I'm going to look at the a to the 5th and a squared. Both of those can be divided by a squared, and you end up with a cubed over 1. B cubed and b cubed can both be divided by b cubed, so you get 1 over 1. And c to the 4th over c to the 9th can both be divided by c to the 4th, so we get 1 over c to the 5th. And so that is the first part, finding an equivalent rational expression in lowest terms. Second, we need to identify all the values the variable must be excluded. So big thing is, when you have a fraction, the denominator can't be 0. You can't divide by 0. So we consider the original unreduced fraction, and if a was 0, that would make the denominator 0, because 0 times anything is 0. If b was 0, that would also be a problem, and if c was 0, that would also be a problem. So we need to exclude a, b, and c from equaling 0 in this problem. Alright, number 6. So in this form, it's not apparent if this can be reduced at all, but factoring helps us see what each the numerator and the denominator are divisible by. So in the numerator we have a trinomial, 3n squared minus 5n minus 2. And I'm going to try factoring that. I'm looking for two numbers that multiply to negative 6 and add to negative 5. You think about that a little bit, you end up with negative 6 and positive 1. So then I rewrite these three terms as four terms: 3n squared minus 6n plus 1n minus 2. So that middle term, the negative 5n, gets split up to negative 6n plus 1n, and now in four terms this will factor by grouping. So the first two we could factor out of 3n. We're left with n minus 2. The last two terms we could factor out of 1, left with n minus 2. And then we can divide each of these terms by n minus 2. So we're going to factor out an n minus 2, and we're left with 3n plus 1. So going back to our fraction, we know the top part factors to n minus 2 times 3n plus 1. The denominator, both 2n and 4 are divisible by 2, so you can factor out a 2, and we're left with n minus 2. Now we can look at the numerator and denominator, see they're both divisible by n minus 2, and so divide them both by n minus 2, and you end up with 3n plus 1 over 2. So that's the first part. We also need to list our excluded values. Well, bottom line is we don't want our denominator to equal 0. So we don't want 2n minus 4 to equal 0, or we could consider we don't want the factored part, the 2 times n minus 2 to equal 0. If you take, well, we know 2 is not 0, so we need n minus 2 not to be 0. And if we solve for n, we need n not to equal 2. So that is our excluded value in this problem. Next, let's take a look at number 7. Here we have f of x minus 2 over f of x squared minus 4 if f of x equals 3x. So I'm going to replace the f of x with 3x. And we end up with 3x minus 2 over 3x squared minus 4, which is 3x minus 2 over 9x minus 4, 9x squared minus 4. Factor to see what each numerator and denominator divisible by. So 3x minus 2 is already factored. And then the 9x squared minus 4 is a difference of two perfect squares, which is 3x minus 2 times 3x plus 2. So I'm going to divide top and bottom by 3x minus 2. If you divide the top by 3x minus 2, you end up with 1. If you divide the denominator by 3x minus 2, you get 3x plus 2. So that's our reduced fraction. Again, we don't want our denominator to equal 0. And to go back to the part before we reduced or before we divided, and I'm going to go to the third stage where it's already factored. So we don't want 3x minus 2 to equal 0, and we don't want 3x plus 2 to equal 0. So 3x cannot equal 2, and 3x cannot equal negative 2. So x cannot equal 2/3 or negative 2/3. So those are your excluded values. Next, take a look at number 13. 13, we have f of x over g of x cubed. F of x is 9 minus x squared. G of x is x minus 3, and that is to the third power. So we can factor the 9x squared. That's a difference of two squares. That's 3 minus x times 3 plus x, and x minus 3 cubed is x minus 3 times x minus 3 times x minus 3. Three minus x is the opposite of x minus 3, and we can rewrite this as negative x minus 3 times 3 plus x is the same as x plus 3, and we have x minus 3 still times x minus 3 times x minus 3 in the denominator. So we can divide numerator and denominator by x minus 3, and we end up with negative x plus 3 divided by x minus 3 squared, or you could write x minus 3 times x minus 3. For excluded values, our denominator cannot equal 0. Our denominator is made of 3 factors of x minus 3. So x minus 3 can't equal 0, which means x cannot equal 3. Next, let's take a look at number 16. 16 we want to factor. So we have 4 terms in the numerator, which can be simplified. You can the negative 3y and the positive 5y can become a 2y, but it is written as 4 terms, so we can check pretty quickly if this factors by grouping first. The first 2 terms we can divide out a y, and we end up with y times y minus 3. The last 2 terms we can divide out a 5, and we get 5 times y minus 3, and this is actually set up for us to factor by grouping. So to keep going, factor out a y minus 3, and we end up with y plus 5. So the top part does factor to that. The bottom part, we have a difference of 2 perfect cubes, and it's y cubed minus 3 cubed, because 27 is 3 to the 3rd power. So this factors to y minus 3 times y, which is y squared, plus y times 3, which is 3y, plus 3 times 3, which is 9. And with your original, we had a minus sign between the y cubed and the 3 cubed, and this part here always has the same sign. This is the opposite of that sign, and this last one's always positive, and so there's our factorization. So now we can come back to our fraction and write y minus 3 times y plus 5 divided by y minus 3 times y squared plus 3y plus 9. And we divide out the y minus 3's, and we end up with y plus 5 over y squared plus 3y plus 9. And for excluded values, we cannot have y minus 3 equaling 0, which means y can't equal 3. And we can't have y squared plus 3y plus 9 equaling 0. But that's not so much of a problem, because when we solve for y here, we get imaginary numbers. Using the quadratic formula, we end up with y is equal to negative 3 plus or minus square root negative 3 squared, which is 9, minus 4 times 1 times 9, all over 2 times 1. And you see that this is going to be negative, which gives us an imaginary number, and we're only worried about real numbers. So there's no real number that we can plug into y squared plus 3y plus 9 that will make that part negative. And so the only excluded value is 3. Or another way to word this is excluded values are only real numbers that make your denominator 0. And that's all we're going to go over from Worksheet 1.